Resistance, Current and Potential Difference Equation by KayScience.com. The higher the resistance, the more energy needed to push the flow of charge through the wires and components. Here is a series circuit containing a cell, an ammeter connected in series, a lamp, and a voltmeter connected in parallel across the lamp. In this example, the ammeter reads 2 amps, the voltmeter reads 5 volts. So because the voltmeter reads 5 volts, this means the cell must be a 5-volt cell. Here is another series circuit containing the same components. This time, the ammeter reads 2 amps as well. However, the voltmeter reads 20 volts. This means the cell must be 20 volts as well. We're going to use these two circuits to explain how current and potential difference are linked to resistance. We can see in the circuit on the right, the cell has a higher potential difference. Yet in both circuits, the ammeter shows the current is 2 amps. Therefore, a higher potential difference of 20 volts to achieve the same current of 2 amps means there is a higher resistance in the circuit on the right compared to the circuit on the left. It's question time. Attempt these questions to check your understanding. Here is a close-up of the metal wire from the circuit on the left. We're going to use this to explain why this circuit has a lower resistance. The red circles with crosses represent the positive lines, and these vibrate about a fixed position, represented by the movement lines in the diagram. These blue E's represent the flow of charge, in other words, the electric current. And we know the electric current is the flow of charge per second. So because this electric current is 2 amps, this means 2 coulombs of charge is flowing per second. And we can see how not much energy is needed to force these electrons through the metal wire, as these electrons do not collide often with the vibrating metal positive ions. As there are less collisions of electrons with vibrating cations, this means less energy is needed to push the electrons through the wire, causing there to be a lower resistance in this circuit. So we already know this circuit on the right has a higher resistance. Now if we zoom in to the metal wire, we can see how the positive metal cations are vibrating more. And as the electrons flow through the metal wire, they collide more frequently with these vibrating metal cations. So to achieve the same current, a larger potential difference is needed to force these electrons through the metal wire. So as there are more collisions of electrons with vibrating cations, where there are more vibrations in these cations, this means more energy is needed to push the electrons through the wire. Therefore, there is going to be a higher resistance in this circuit. It's question time. Attempt these questions to check your understanding. This understanding of resistance can help us to remember the equation to calculate resistance, which is resistance equals potential difference divided by current. The symbol of resistance is a capital R, and the unit of resistance is ohms. And the symbol of the unit is an omega letter from the Greek alphabet. The symbol of potential difference is a capital V, and the unit is volts, which has a symbol of a capital V as well. And finally, the symbol of current is a capital I, where the unit is amperes, also known as amps, which has a symbol of a capital A. We can write this equation just using the symbols. where R equals V over I. It's question time. Attempt these questions to check your understanding. Pause the video here to practice the keywords. The answers will follow. Press pause to answer the questions. The answers will follow. If stuck, just re-watch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.